When we picture gold mining, we usually imagine chunks of pure metal pulled directly from the earth. But to reach the scale of commercial production you see here, the industry relies on a complex chemical extraction process. For over a century, the global standard for that process has been cyanidation. Mining operations depend on cyanide because the math makes sense. The chemical is cheap to synthesize, the application process is operationally simple, and it reliably strips gold from raw ore. But that reliance comes with an inherent risk. Cyanide is exceptionally toxic. If the waste liquid generated during extraction leaks into the surrounding ecosystem, it creates an immediate environmental hazard. Beyond the obvious danger, cyanide also has a mechanical drawback. The chemical reaction required to actually immerse and extract the gold is surprisingly slow. The entire global extraction industry is built on a volatile foundation, relying on an environmental liability that ultimately acts as a drag on production timelines. Efficiency drops further when ore contains copper, iron, lead, or zinc. The cyanide reacts with these impurities instead of targeting the gold. As this chart shows, when the volume of competing metals rises, the overall gold recovery rate drops. While operations lose money to inefficiency, legislative bodies are tightening the net. Governments are implementing strict new environmental protection laws and preparing to levy heavy pollution taxes on mining operations. With chemical efficiency dropping and the financial penalties for environmental damage soaring, mining operations are actively searching for a different extraction technology. The answer comes in the form of low-toxic, eco-friendly chemical agents engineered to completely replace sodium cyanide in the extraction process. The viability of these agents stems from their logistics. A mine can transition to this new chemistry without dismantling or rebuilding its billion-dollar footprint. They function as a direct drop-in substitute. In facilities like this, which use carbon-in-pulp and carbon-in-leach processes, the new agents are poured right into the existing vats alongside the lime used to maintain an alkaline pH. This direct compatibility allows mining corporations to eliminate the risk of a toxic spill from their operations without halting production or abandoning their current capital investments. To understand why these new chemicals outperform cyanide, we have to look at the process on a molecular level. Similar to the traditional method, the eco-agent relies on a chemical reaction between solid gold particles and an oxygen-rich solution. The dissolution happens in two distinct stages. First, the agent begins attacking the solid gold. As the gold dissolves, this specific reaction produces hydrogen as a chemical byproduct. Then, in the second stage, hydrogen peroxide and the agent's unique chemical compounds sweep in to dissolve the remaining gold fragments. The chemical byproducts produced in these stages act as a catalyst, accelerating the reaction and aggressively stripping the gold while the surrounding impurities remain inert. Once the extraction is complete, these highly active substances naturally degrade. The process acts aggressively on the ore, but remains safe for the surrounding environment. This chemical efficiency addresses a massive supply problem for the global market. The world's easily accessible gold veins are largely depleted, leaving operations to sift through massive volumes of low-grade or refractory ores. Traditional cyanidation often lacks the power to extract meaningful value from these complex, impurity-heavy rocks. While eco-friendly agents still face hurdles regarding production costs and large-scale industrial adaptation, their unique ability to ignore copper and iron impurities makes them the most effective way to process this low-grade material. These agents represent the specific technical key required to process the world's remaining refractory gold reserves, transforming previously unusable rock into a viable resource. By combining a faster gold recovery rate with a negligible risk of ecological contamination, this new chemical process addresses both the mechanical and environmental flaws of the past century. As governments around the world codify strict financial penalties for pollution and toxic leaks, the era of relying on dangerous cyanide is closing. The shift toward degradable agents is a direct response to a global mining environment where toxic risk is becoming too expensive to manage.